Hello friends, today we are going to learn about digital multimeter, how to operate digital multimeter. As you can see, the pointer is set to the off position, so the multimeter is off now. But first we are going to see AC range where we can check our AC volts with this meter. So here is volt sign with AC. It means we can check AC volts here. It's written 200 volts and it's written 750 volts. So we can check our AC volts in two range here. 200 means volt up to 200 volts and 750 means up to 750 volts. We will choose the range 750 if we are going to check the volts beyond 200 volts. Now we are going to talk about DC volts range. In this range we can check our DC volts. We have ranges 200 millivolts, 2000 millivolts, 20 volts, 200 volts and 1000 volts. But we can do our main task between 20 volts and 200 volts DC range. We can check our cells easily at 20 volts DC range. Now we will talk about resistance. We can see our ohm symbol here. The range starts from 200 ohm, 2000 ohm, 20k, 200k and 2000k. We can measure up to 2000k. We have a sign of like a speaker, which is a range for continuity. Here we can check all our fuse or wire if it is broken or not, and below that there is a sign. It is for checking of diodes. After that it comes a sign which shows frequency range, and after that there is a sign written HFE. It is used for measuring HFE of transistors. Here is a socket where we can check our transistors whether it's NPN or PNP, whether it's okay or not. We will talk it about later. And then we have DC ampere range that shows 2000 microamperes, 20 milliamperes and 200 milliamperes. And there is a 10 ampere sign of DC here. Now we have three sockets here. This one is common or used for negative or black wire. This one shows V ohm milliampere sign. It is used for red wire. This one is only used when we check DC ampere range. And another digital multimeter which is more advanced than first one, and I use it for my personal use. So now we are going to talk about this advanced multimeters and its features. First I am telling you where we will attach our both wires. We can see the red and the black symbols here. Red is for red wire and black is for black wire. I am going to attach wires. Please check. See, both wires are properly connected now. Here we can see a switch which is a on off switch. Now this is the switch for on off, and this is our DC volts range where we have 400 millivolts, 4 volts, 40 volts, 400 volts and maximum 1000 range of AC. As you can see, our range is selected 40 volts DC range, in which we can do our main works It is our hold switch. This is our DC ampere range, 40 milliampere, 400 milliampere and 10 ampere range. Now check how we will change the wires if we are going to check 10 amperes. The red wire will shift from here to here, and if we have to use milliampere range like 40 milliampere or 400 milliampere DC, then simply we will do this trick. We will change the wire from here to here. Now we can check our DC ampere very easily. For all other checkings, we have to connect red wire here. This is the right way for the red wire. Now we are going to talk about AC volts. We have different ranges here: 400 millivolts, 4 volts, 40 volts, 400 volt AC, 750 volts. 400 volts AC means up to 400 volts AC, not beyond that. It is a safe range to check volts in India, that is 220 to 240 volts. Now we are going to talk about AC amperes. We have again range 40 milliampere, 400 milliampere and 10 ampere AC. Now how to manage the wires? Let's check again. If we are going to check milliamperes AC, then we simply shift our wire from here to here. But if we are going to check 10 amperes AC, then the wire will go from here to here. Now we are going to check capacitor section, and this is all range and F written here. All these ranges are used to check different capacitors. These are two sockets to check capacitors. It is written very clearly: discharge capacitor before test. So we have to discharge our capacitor before putting it into this sockets, otherwise this will destroy the meter. Now we are going to check our HFE, and this is our HFE range for transistors. You can see these two sockets written NPN and PNP on it. We can check all our transistors here. Now we are going to check our resistance range. Ohm symbol is here. So check all the ranges. That starts from 400 ohm, 4 kilo ohm, 40 kilo ohm, 400 kilo ohm, 4 mega ohm, 40 mega ohm and 400 mega ohm. So we have plenty of range to check resistance. 400k means up to 400k, not beyond that. 4 meg means up to 4 meg, not beyond that. Now there is a sign of speaker in front of 400 ohm, which is used for continuity, and this is now this is a sign for diode to check all diodes, and this is a sign to check continuity. After diode, we have another sign here that shows KHZ, means we can check some frequency in this meter, and there is also one sign logic. It shows us logic of high or low. Now I am going to check DC volts with this meter, so I am attaching my wires. I have selected 40 volt DC range. Now I am going to switch on the power button. Now the reading is 00. Now I am going to check a pencil cell which provides us DC volts. You can see very clearly there is a plus and a minus sign on this cell. Plus shows positive, minus shows negative. Now we check the volts of this cell, whether the cell is okay or not. Now we connect the wires to the cell. Red wire at plus and black wire at minus point of cell. The meter is showing reading approximately 1.49, and an average pencil cell has a range 1.50, so the cell is perfectly okay because it's showing 1.49 volts. You can see it very clearly. Now what will happen if we change our wires? Suppose I put the red wire on negative and black wire on positive. What will happen if in the reading of the meter? Let us check now. You can see the reading is same as I have changed the wires, but reading is same. But when I was checking with wrong polarity of wires, it is showing a minus sign in front of our reading. Look at it clearly. This is a minus sign in front of our reading, but the volts are same, 1.49. Now again we are going to put our red wire at positive and black wire at minus terminal of the cell. So now there is no minus sign on the meter reading. Again I am going to change the wires, red wire at minus and black wire at positive. Again we will check what happens. The result is same, minus in front of our reading. It shows that we have put our wires at wrong places. Switch off the meter as it consumes battery. Now we are going to check our AC supply, that is our main supply. Now I am going to adjust the meter at 400 volts AC range, and we are going to check our mains. I am going to switch on the meter to check our main supply. Check the meter for proper settings. Now meter is on and I am going to check the AC supply from mains. So please look at it very carefully. See, my black wire is at left side and red wire is at right side, and the switch is on. Now let's check the reading. It's 232 volts approximately. That is a regular supply in India. Now I have changed the wires, red at left and black at right. Switch is on. Now check the reading. Now it's again same, but now it is showing no signs of negative or positive because AC has no polarity. And in India our volt range is 220 to 240 volts, so the supply is 100% okay.